Let us talk about the equilibrium of forces. Equilibrium in a 2-force system. For a body to be in equilibrium under the action of two forces, those forces must be collinear, equal in magnitude and act in opposite directions, as illustrated in figure 1. That means here we can see this one, figure 1. These two forces are collinear in the sense in the line of action is same and opposite in direction and equal in magnitude. Then only these two forces will be said to be in equilibrium. The body will not be in equilibrium if it is acted upon by two equal and opposite parallel forces, as this results in a couple which produces rotation. If it is two equal and opposite parallel forces, if they are not collinear, they are parallel in nature, then it will cause a rotation. For example, if the force is here like this and this force is like this, it will cause it to rotate. These two are parallel forces means. So that will produce rotation. In that scenario, results that is a couple that will produce a rotation. Here we will see what is the definition of equilibrium in the context of two-force system. Equilibrium in a two-force system occurs when two forces act on a body such that they are equal in magnitude and collinear and act in opposite directions. This balance results in no net force acting on the body, keeping it at rest or in uniform motion. Why can't a body be in equilibrium under two equal and opposite parallel forces? If they are parallel, when two equal and opposite forces act on a body, they create a couple, that means which induces rotational motion. Even though the linear forces balance out, the rotation means the body cannot remain in state of equilibrium. So here you can see in a two-force system, the body is in equilibrium when two forces act on it that are collinear, that means they act along the same line, equal in magnitude, they are equal in strength, opposite in direction, they act in opposite directions, they act along the same line of action is same, and they are equal in strength. We can see an example. Consider a beam supported at its center, two equal vertical forces 500 Newton acting upwards. If the beam is also subject to a downward force of 1000 Newton at the center, the forces can be represented as 500 kN upwards, another 500 kN upwards, minus 1000 downwards. The equilibrium conditions can be expressed as F1 plus F2 plus F3 equals 0. That means 500 plus 500 minus 1000 equals 0. This is one introduction, means of meaning we can say. Professor Force, his name. Welcome everyone. Today we are exploring the fundamental concepts of equilibrium in different force system. Let's start with the two-force system. Engineer Illa, could you explain this to us? Absolutely. In two-force system, we need two key conditions for the equilibrium. Forces must be collinear, equal in magnitude, and act in opposite directions. For instance, if two forces F1, F2 both equal 10 kN but pulling in opposite directions, we can express this mathematically. F1 plus F2 equals 0. This is 0. Great point. But remember, if these two forces are equal and parallel but not collinear, they create a couple leading to rotation rather than equilibrium. Exploring the couple, Sinjin are right. Let's visualize that. If I pull left with 100 kN and pull right with 100 kN, 10 Newton, but on different lines, this will create a couple. This results in a torque. She uses her hands to show the concept of rotation. Exactly, the net force remains 0, but a rotation can cause the object to spin. The torque is defined as torque T equal to R times F. R is the distance from the pivot point to the line of action of the force. When the three-force system, you will see, when the body is in equilibrium under three forces, those forces must be either concurrent or parallel. To satisfy the condition, summation of m equals 0, the lines of action of three non-parallel forces must meet a common point. Here you can see these three forces are not parallel, but the line of action meet at a common point. So the summation of moment about this point is 0. If three forces P1, P2, P3 are parallel, act in the same direction, the body will not be in equilibrium because the resultant R is given as P1 plus P2 plus P3. Conversely, if the forces act in opposite directions, one like this, opposite directions, and their magnitudes are adjusted such that the resultant force is 0, while the sum of moments about the point is also 0, then the body will achieve the equilibrium. Sum of moments about any point should be 0. Lami's theorem states that if the body is in equilibrium under the action of three concurrent forces, then each force is proportional to the sine angle between the other two forces. Suppose if these are the three forces, this force opposite angle, this opposite angle, three forces. For example, this is the P1 means this angle, opposite angle we have to see. P1 sine alpha, P2 sine beta, P3 sine gamma, like that it should come. That will be that will be the, if the body is in equilibrium, this under the action of three concurrent forces, then each force is proportional to the sine of angle between the other two forces. Let three forces acting at a point O, this is a point O, three forces P1, P2, P3, P1, three forces P1, P2, P3 acting, and opposite to the P1 is gamma angle, then opposite to P2 is beta, opposite to P3 is alpha angle. Then according to this Lami's theorem, we have P1 by sine alpha equal to P2 by sine beta equal to P3 by sine gamma. So steps for equilibrium analysis of body. Draw free body diagram. Create diagram that shows all the forces and moment acting on the body. Write the equilibrium equations. Establish equations for all forces and moments depicted on the free body. Solve the equilibrium equations. Use the established equations to find the unknown variables. So what conditions must be satisfied for a 3-force system to achieve equilibrium? For a 3-force system to be in equilibrium, 3 forces must be concurrent, meaning they meet a common point. Concurrent means they meet a common point, or they must be parallel and balanced in opposite directions so that their resultant force is 0. How do you determine if three non-parallel forces are in equilibrium? To determine if three non-parallel forces are in equilibrium, check if their lines of action meet at a common point. If their lines of action meet at a common point, then they are said to be concurrent. Additionally, they ensure the sum of moments around a point, any point, is 0, which confirms rotational equilibrium. Can three parallel forces be in equilibrium? Three parallel forces can be in equilibrium if they act in opposite directions and their magnitudes are such that the resultant forces equal to 0. If they all act in the same direction and the body will not be in equilibrium, as there will be a net force.